Persistent Organic Pollutants, or POPs, are a set of toxic chemicals that persist in the environment and can last for several years before breaking down. POPs circulate globally, and chemicals released in one part of the world can be deposited at far distances from their source through a repeated process of evaporation and deposition. This makes it very hard to trace the source of the chemical. POPs are lipophilic, meaning they accumulate in the fatty tissue of living animals and humans. In fatty tissue, the concentrations can become magnified by up to 70,000 times higher than the background levels. As you move up the food chain, concentrations of POPs tend to increase so that animals at the top of the food chain, such as fish, predatory birds, mammals, and humans, tend to have the greatest concentrations of these chemicals and therefore are also at the highest risk from acute and chronic toxic effects. The term dirty dozen refers to the original 12 banned pesticides and industrial chemicals under the Stockholm Convention. The original Stockholm Convention list consists of persistent organic pollutants, POPs, a group of chemicals initially targeted for global elimination or restriction under the Stockholm Convention on Persistent Organic Pollutants in 2001. This includes pesticides like Chlordane, Chlordane, and DDT, as well as industrial chemicals like PCBs and byproducts like dioxins. This list was part of the Stockholm Convention and included highly toxic and persistent chemicals. These chemicals bioaccumulate in living organisms, travel long distances, long-range atmospheric transport, and pose serious health risks: carcinogenic, endocrine-disrupting, neurotoxic, immunotoxic. They fall into three major classes: pesticides, industrial chemicals, and unintentional byproducts. Pesticides: Chlordane, Chlordane, DDT, dieldrin, endrin, heptachlor, Mirex, and toxaphene. Industrial chemicals: hexachlorobenzene and polychlorinated biphenyls, PCBs. Byproducts: dioxins and furans. Chlordane. Insecticides are used on crops like corn and cotton. They metabolize to dieldrin, even more persistent. Chlordane insecticide was used on crops like corn and cotton, but its use has been banned in the U.S. since 1974 due to environmental and health concerns. It was used to control soil insects, but because it is a persistent organic pollutant that breaks down into dieldrin in the environment and body, it was eventually banned for all uses in 1987. In one incident, Chlordane-treated rice is believed to have killed hundreds of shorebirds, waterfowl, and passerines along the Texas Gulf Coast, when these birds either ate animals that had eaten the rice or ate the rice themselves. In humans, the fatal dose for an adult male is estimated to be about 5 grams. Humans are mostly exposed to Chlordane through dairy products and animal meats. Studies in India indicate that the average daily intake of Chlordane and its byproduct dieldrin is about 19 micrograms per person. Dieldrin. Used for termite control and agriculture. Highly toxic, long-term residues in soil. Dieldrin was used for both termite control and agricultural pest control, but its use has been banned in most applications due to its persistence and toxicity. It was widely used on crops like corn, cotton, and citrus from the 1950s to the 1970s, and for termite control until 1989. The U.S. EPA banned most uses of dieldrin in 1974, except for its use for termite control until 1989. Used principally to control termites and textile pests, dieldrin has also been used to control insect-borne diseases and insects living in agricultural soils. Its half-life in soil is approximately 5 years. The pesticide Chlordane rapidly converts to dieldrin, so concentrations of dieldrin in the environment are higher than dieldrin use alone would indicate. Dieldrin is highly toxic to fish and other aquatic animals, particularly frogs, whose embryos can develop spinal deformities after exposure to low levels. Dieldrin residues have been found in air, water, soil, fish, birds, and mammals, including humans. Food represents the primary source of exposure to the general population. For example, dieldrin was the second most common pesticide detected in a U.S. survey of pasteurized milk. Chlordane. Insecticide for termites. Agriculture. Very stable. Detected decades after use, stops. Chlordane was a broad-spectrum insecticide used in the United States for termites and agricultural pests on crops like corn and citrus, but it was banned for most uses in 1988 due to health and environmental concerns. While it was phased out for agricultural and home use starting in 1978, its use for subterranean termite treatment around building foundations was permitted until the final ban in 1988. Chlordane is persistent, bioaccumulative, and classified as a possible human carcinogen, which led to its widespread cancellation. Used extensively to control termites and as a broad-spectrum insecticide on a range of agricultural crops, Chlordane remains in the soil for a long time and has a reported half-life of 1 year. The lethal effects of Chlordane on fish and birds vary according to the species, but tests have shown that it can kill mallard ducks, bobwhite quail, and pink shrimp. Chlordane may affect the human immune system and is classified as a possible human carcinogen. It is believed that human exposure occurs mainly through the air, and Chlordane has been detected in the indoor air of residences in the U.S. and Japan. Endrin. Insecticide and rodenticide. Causes neurological effects. Endrin is a solid, white, almost odorless substance that was used as a pesticide to control insects, rodents, and birds. Endrin has not been produced or sold for general use in the United States since 1986. This insecticide is sprayed on the leaves of crops such as cotton and grains. It is also used to control rodents such as mice and voles. Animals can metabolize endrin, so it does not accumulate in their fatty tissue to the extent that structurally similar chemicals do. It has a long half-life, however, persisting in the soil for up to 12 years. In addition, endrin is highly toxic to fish. When exposed to high levels of endrin in the water, sheepshead minnows hatched early and died by the 9th day of their exposure. The primary route of exposure for the general human population is through food, although current dietary intake estimates are below the limits deemed safe by World Health authorities. Heptachlor. Insecticide for termites, soil insects. Degrades to heptachlor epoxide, highly persistent. Heptachlor is a persistent insecticide that was banned for most uses in the U.S. in 1988, but its use is still restricted for fire ant control in power transformers. It is highly toxic to aquatic life, can cause health problems like headaches and nerve damage, and is classified as a probable human carcinogen. Because of its persistence, exposure can still occur through contaminated food, especially dairy, fish and meat, soil, air, and water. Primarily used to kill soil insects and termites, heptachlor has also been used more widely to kill cotton insects, grasshoppers, other crop pests, and malaria-carrying mosquitoes. It is believed to be responsible for the decline of several wild bird populations, including Canadian geese and American kestrels, in the Columbia River Basin in the U.S. The geese died after eating seeds treated with levels of heptachlor lower than the usage levels recommended by the manufacturer, indicating that even responsible use of heptachlor may kill wildlife. Laboratory tests have also shown high doses of heptachlor to be fatal to mink, rats, and rabbits. with lower doses causing adverse behavioral changes and reduced reproductive success. Heptachlor is classified as a possible human carcinogen. Food is the major source of exposure for humans, and residues have been detected in the blood of cattle from the US and from Australia. Hexachlorobenzene, HCB. Used as a fungicide for seeds, also an industrial byproduct. Bioaccumulates heavily in food chains. Hexachlorobenzene, HCB, is a pre-emergent fungicide and is ubiquitous in the environment. It has been isolated in the reproductive tract in several species, including humans. First introduced in 1945 to treat seeds, HCB kills fungi that affect food crops. It was widely used to control wheat bunt. It is also a byproduct of the manufacture of certain industrial chemicals and exists as an impurity in several pesticide formulations. When people in eastern Turkey ate HCB-treated seed grain between 1954 and 1959, they developed a variety of symptoms, including photosensitive skin lesions, colic, and debilitation. Several thousand developed a metabolic disorder called porphyria turcica, and 14% died. Mothers also passed HCB to their infants through the placenta and through breast milk. In high doses, HCB is lethal to some animals and, at lower levels, adversely affects their reproductive success. HCB has been found in food of all types. A study of Spanish meat found HCB present in all samples. In India, the estimated average daily intake of HCB is 0.13 micrograms per kilogram of body weight. Mirex. Insecticide and fire retardant. Highly persistent, nearly insoluble. Mirex is an organochlorine compound, a synthetic and highly persistent one that was used as an insecticide and a flame retardant. Its chemical stability and tendency to bioaccumulate led to environmental and health concerns, resulting in its global ban under the Stockholm Convention on Persistent Organic Pollutants. This insecticide is used mainly to combat fire ants, and it has been used against other types of ants and termites. It has also been used as a fire retardant in plastics, rubber, and electrical goods. Direct exposure to Mirex does not appear to cause injury to humans, but studies on laboratory animals have caused it to be classified as a possible human carcinogen. In studies, Mirex proved toxic to several plant species and to fish and crustaceans. It is considered to be one of the most stable and persistent pesticides, with a half-life of up to 10 years. The main route of human exposure to Mirex is through food, particularly meat, fish, and wild game. Toxaphene. Insecticide used on cotton. Complex mixture of chlorinated hydrocarbons. Toxaphene is a persistent, highly toxic organochlorine pesticide that was banned in the US in 1990 but remains in the environment and bioaccumulates in fatty tissues. It is a mixture of over 670 chlorinated camphenes with a strong, piney odor. Exposure can damage the central nervous system, liver, and kidneys, and it is classified as a probable human carcinogen based on animal studies. This insecticide is used on cotton, cereal grains, fruits, nuts, and vegetables. It has also been used to control ticks and mites in livestock. Toxaphene was the most widely used pesticide in the US in 1975. Up to 50% of a toxaphene release can persist in the soil for up to 12 years. For humans, the most likely source of toxaphene exposure is food. While the toxicity to humans of direct exposure is not high, toxaphene has been listed as a possible human carcinogen due to its effects on laboratory animals. It is highly toxic to fish. Brook trout exposed to toxaphene for 90 days experienced a 46% reduction in weight and reduced egg viability, and long-term exposure to levels of 0.5 micrograms per liter of water reduced egg viability to 0. DDT, dichlorodiphenyltrichloroethane. Famous insecticide for malaria control. Still allowed in controlled public health uses. Vector control. DDT is a synthetic organochlorine insecticide that was widely used in the past but is now banned for most uses due to its persistence and toxicity. Initially, its effectiveness in controlling insect-borne diseases like malaria and typhus made it a valuable tool for public health during World War II. However, DDT is toxic to aquatic life and animals, causes health issues in humans, including a probable link to cancer, and bioaccumulates in the environment, leading to widespread bans. After the war, DDT continued to be used to control disease, and it was sprayed on a variety of crops, especially cotton. DDT continues to be applied against mosquitoes in several countries to control malaria. Its stability, its persistence, as much as 50% can remain in the soil 10 to 15 years after application, and its widespread use have meant that DDT residues can be found everywhere. Residual DDT has even been detected in the Arctic. Perhaps the best-known toxic effect of DDT is eggshell thinning among birds, especially birds of prey. Its impact on bird populations led to bans in many countries during the 1970s. Although its use had been banned in many countries, it has been detected in food from all over the world. Although residues in domestic animals have declined steadily over the last 2 decades, foodborne DDT remains the greatest source of exposure for the general population. The short-term acute effects of DDT on humans are limited, but long-term exposures have been associated with chronic health effects. DDT has been detected in breast milk, raising serious concerns about infant health. The DDT web section covers overview, guidance, evaluation of continued use, DDT register, DDT toolkit, etc. Global Alliance for promoting a global partnership on the development and deployment of alternative products, methods, and strategies to DDT for disease vector control is also available. Polychlorinated biphenyls, PCBs, used in transformers, capacitors, and lubricants. Extremely persistent, bioaccumulates in aquatic food chains. Polychlorinated biphenyls, PCBs, are man-made, toxic industrial chemicals that are no longer produced in the U.S., but persist in the environment and can cause health problems. Once used for their stability in products like electrical equipment, paints, and plastics, PCBs are known probable human carcinogens that can negatively impact human health and bioaccumulate in the food chain. Exposure occurs through contaminated food, water, soil, or contact with old products. These group of chemicals possesses properties including longevity, heat absorbance, and form an oily liquid at room temperature that is useful for electrical utilities and in other industrial applications. Due to their physicochemical properties, PCB were manufactured worldwide for use in a wide range of applications, most importantly as insulating wire and heat exchange fluids in transformers and capacitors and other electric equipment, and in open applications such as additives in paint, carbonless copy paper, and plastics. PCBs are toxic and can cause serious health effects in humans and animals, including reproductive impairment and immune system dysfunctions. The International Agency for Research on Cancer, IARC, classified PCB as Group 1 carcinogenic to humans. Of the 209 different types of PCBs, 13 exhibit a dioxin-like toxicity. Their persistence in the environment corresponds to the degree of chlorination, and half-lives can vary from 10 days to 1.5 years. Once in the environment, PCBs enter the food chain. PCBs have been detected in human milk, and in some cases, observed levels of PCB were found to be several orders of magnitude higher than the WHO safety level. Large numbers of people have been exposed to PCBs through food contamination. Consumption of PCB-contaminated rice oil in Japan in 1968 and in Taiwan in 1979 caused pigmentation of nails and mucous membranes and swelling of the eyelids, along with fatigue, nausea, and vomiting. Due to the persistence of PCBs in their mothers' bodies, children born up to 7 years after the Taiwan incident showed developmental delays and behavioral problems. Similarly, children of mothers who ate large amounts of contaminated fish from Lake Michigan showed poorer short-term memory function. PCBs also suppress the human immune system and are listed as probable human carcinogens. PCBs are toxic to wildlife, including fish, killing them at higher doses and causing spawning failures at lower doses. Research also links PCBs to reproductive failure and suppression of the immune system in various wild animals, such as seals and mink. Polychlorinated dibenzo-p-dioxins, PCDDS, formed during combustion, chlorine bleaching of pulp, and waste incineration. Extremely toxic, EGB, TCDD. Polychlorinated dibenzo-p-dioxins, PCDDs, commonly known as dioxins, are a group of toxic, persistent organic pollutants that are not intentionally manufactured but are unintentionally created as byproducts of industrial processes like waste incineration and chlorine bleaching. They are highly persistent in the environment and can accumulate in the fatty tissues of living organisms, with exposure to high doses linked to health problems like cancer in animals. These chemicals are produced unintentionally due to incomplete combustion, as well as during the manufacture of pesticides and other chlorinated substances. They are emitted mostly from the burning of hospital waste, municipal waste, and hazardous waste, and also from automobile emissions, peat, coal, and wood. There are 75 different dioxins, of which 7 are considered to be of concern. One type of dioxin was found to be present in the soil 10 to 12 years after the first exposure. Dioxins have been associated with several adverse effects in humans, including immune and enzyme disorders and chloroquine, and they are classified as possible human carcinogens. Laboratory animals given dioxins suffered a variety of effects, including an increase in birth defects and stillbirths. Fish exposed to these substances died shortly after the exposure ended. Food, particularly from animals, is the major source of exposure for humans. Polychlorinated dibenzofurans, PCDFS. Similar to dioxins generated in industrial processes and fires. Polychlorinated dibenzofurans, PCDFS, are a family of organic compounds with one or several of the hydrogens in the dibenzofuran structure replaced by chlorines. Dibenzofurans are known as Persistent Organic Pollutants, POPs, classified among the Dirty Dozen in the Stockholm Convention on Persistent Organic Pollutants. These compounds are produced unintentionally from many of the same processes that produce dioxins, and also during the production of PCBs. They have been detected in emissions from waste incinerators and automobiles. Furans are structurally similar to dioxins and share many of their toxic effects. There are 135 different types, and their toxicity varies. Furans persist in the environment for long periods and are classified as possible human carcinogens. Food, particularly animal products, is the major source of exposure for humans. Furans have also been detected in breastfed infants. POPs are highly toxic, and exposure can take place through diet, environmental exposure, or accidents. They negatively affect humans, plant and animal species, and natural ecosystems both in proximity and at significant distances away from the source of discharge. Exposure to POPs in humans can cause several negative health effects, including death, cancers, allergies, hypersensitivity, developmental changes, damage to the central and peripheral nervous systems, disruption of the endocrine, reproductive, and immune systems. A study published in 2006 suggests that an increased level of POPS in human blood serum can be linked to diabetes. Lee et al., 2006. According to the U.S. Environmental Protection Agency, EPA, there are links between POPS exposure and the increased frequency of diseases and/or abnormalities in wildlife species, including certain kinds of fish, birds, and mammals. The negative effects of pesticides in the marine and coastal environments include changes in reef community structure, such as decreases in live coral cover and increases in algae and sponges, and damage to seagrass beds and other aquatic vegetation from herbicides. What can you do? Stay informed and act responsibly. Always read the labels and follow instructions. Protect your children from all chemicals since they are more sensitive to toxic substances. Protect pregnant women since exposure could harm the fetus/baby's health. Exposure to pesticides can cause miscarriage and birth defects. Eat ecologically grown vegetables and meats whenever possible. Support companies that make clean products. Ask before buying. Recycle batteries. Recycle the remains of paint, garden pesticides, and all other chemicals. Recycle oil from vehicles. Recycle medicines. Recycle all electronic equipment. Pesticides are poisons. Avoid using them whenever you can. If you decide that you must use a pesticide, always choose the least toxic product. Use environmentally friendly cleaning products for cleaning and washing. Landscape with native plants.